All right, now let's look at an example where we're going to kind of apply and look at a geometric sequence. Here we see that we have a table that shows the population of the United States in 2000 and 2010 with estimates given by the Census Bureau between 2001 and 2009. So if I have this table here, I want to look at the table and I want to show whether or not the population is increasing geometrically. So doing a similar process to what we did in the last video. I've got to show that the ratio between the numbers in my series is going to be constant. So when I come in here, I'm going to take this value, 284. I'm going to divide it by 281.4, and when I do that, I come up with the value 1009. If I were to check this ratio, 286.6 divided by 284.0, I would find that that is also 1009. And you can do it for a couple of more if you want, but because I am finding that the common ratio between these numbers is 1.009, I can say that this is a geometric series, and I would be able to then conclude that the population for us in the United States for any year is going to be 1.009 times the population of the previous year. It also tells me, in other words, what my rate of growth is going to be. Now, if I want to write the general term for the geometric sequence, modeling the population in the U.S. in years after 1999, that's when I go back up and I want to look at this part right here. So I'm going to use this idea, this formula, to be able to model or write a sequence for me to be able to project things, so to speak, later on. So the nth term says a sub n is equal to a sub 1 times r to the n minus 1. Now the general term for this is simply going to be filling in these values. I know that a sub 1, where does this value start? It's going to start in years after 1999. So in other words, we're going to use this value up here. A sub 1 will be 281.4 million. We multiply that times what we already found r to be, which is the 1.009, and we raise that to the n minus 1. That's the general term for this sequence. In other words, I could find out what the population was for any given year after 1999 following this model that you see. And what we're going to do in the very next question says, okay, can you project then what the population is going to be in 2020? So 2020 is the end value, and 1999 is my start value. So n would be 2020 minus 1999, and that's going to be 21. So in other words, n is going to be a sub 21. We're going to find out what a sub 21 would be in this particular sequence using the model right here. I have the a1, which is 281.4 times 1009 raised to the 21 minus 1, which will be 20. And this value, whatever that number is from my calculator, is going to be this 21st sequence. 21, it's going to be the 21st term in my sequence. When I multiply that out on the calculator, you get approximately 336.6 million people by 2020. And that's how we can kind of use a geometric sequence on our population to project it in the future. Let's kind of continue with that same concept, and let's do two more examples here. Similar to what we just did in the very previous by projecting the population. This particular question says I want to find the 5th term and the nth term if I'm given that a1 is 2 and r is equal to 3. So if I want to know what the 5th term would be, that looks like a sub 5 equals 2, and we're just going back in and we're plugging it into my general form right here. So a sub 5 is equal to a sub 1, which would be 2, times r, which is 3, raised to the 5 minus 1, which is 4. Calculate that out, and you have 162. That would be the value of the fifth term. Now what if I want to know what the nth term would be? The nth term, which would be this, says a sub n would be equal to the first term, 2, times r, which is 3, raised to the n minus 1. And that would be the nth term. So both of those answer that question. Okay, and finally, let's just practice one more. Let's say I want to know what the seventh term is of this sequence that we see here. The first term of the sequence is a1, and that's number 1. I need to determine what r is. R is going to be the ratio of the second term, 1/2, divided by the first term, which is 1. So that's pretty easy. R is 1. So if I'm looking for the seventh term, we say a sub 7 would be equal to the first term times r raised to the 7 minus 1, which would be 6, and that gives me 1 over 64. That's the seventh term of this geometric sequence that you see right there.